Hi, in this video, what we'll do is look at the RL circuit again, but this time we're going to use the phasors to solve for the input and output, okay? So I have a phasor voltage applied here, and I have a phasor current applied here, and let's see how we get on with the solution to this problem. Now, for the resistor R, even in the phasor domain, the impedance is given by R, right? But for the inductor L, the impedance is given by j omega L, right? That's what we looked at. Okay, so how would the voltage and current relate to each other? You can write voltage V bar equal to the voltage drop across this resistance, which is going to be IR, and the voltage drop across this inductor, which is going to be I times j omega L. Okay, so let's write that. So RI plus j omega L I. And this, of course, becomes R plus j omega L I bar. Okay, and we can write this complex number, which is given by this R plus j omega L, in its polar form, right? So if you write it in its polar form, so it will have an amplitude and it is going to have a phase, and let's call that phase, let's say alpha. Okay, so what is A going to be? A is going to be square root of R square plus omega L square. And what is alpha going to be? Alpha is going to be tan inverse omega L over R. Right? So what I want is, I want the relationship between the amplitude of I and the amplitude of V, and the phase of V and the phase of I. So to do that, let's expand these phasor variables and write it in its polar form. Okay, so let's write it as Vm. Let's say that's the amplitude, and let's write the angle of the voltage as theta, and then let's write A alpha, and again Im angle, let me write it as phi. Okay, so this is going to become A times Im. Now if you remember your polar arithmetic from complex numbers, when you multiply two complex numbers and in their polar form, the amplitudes gets multiplied and the phases gets added. So we have alpha plus phi. Okay, and now it's very easy to find out the relationship between Im and Vm, right? So what is Im going to be? Im is equal to Vm over A, which is going to be Vm over square root of R square plus omega L square. And what is alpha plus phi is equal to theta, right? So this implies phi is equal to theta minus alpha. Okay, and therefore we have phi. If you assume that your theta, your initial angle, is 0, then phi becomes equal to minus alpha, which is minus tan inverse omega L over R. And you can see that the solution is the same as what we got before in the using the cosine waves and using the complex exponential, but the solution is much simpler.